Welcome to Sapience Learning, your gateway to book summaries.
Chaos by James Gleick. Somewhere in the 1960s, in a quiet room filled with humming computers and the faint smell of coffee and dust, a meteorologist made a mistake, a tiny one. He rounded a number, just a single decimal point. And in doing so, he helped uncover one of the most mind-bending discoveries in modern science: chaos. James Gleick's Chaos is the story of how scientists learned that disorder, not order, might be the real language of nature. It's about patterns in randomness, order in confusion, and the invisible rules guiding the wild dance of the universe. Favorite quote from the author: "Billions of years ago there were just blobs of protoplasm. Now billions of years later here we are. So information has been created and stored in our structure, created from connections that were not there before." Here are 3 fascinating lessons from Chaos, a book that turns the unpredictable into something beautifully meaningful. Lesson 1: The Butterfly Effect: How the Smallest Things Change Everything. Edward Lorenz was trying to predict the weather. He entered a few numbers into his computer: wind speed, temperature, air pressure, and ran the model. Then one day, to save time, he rounded a number from 0.506127 to 0.506. When he checked the results, the forecast had changed completely. It was as if the entire system, the clouds, the winds, the rain, had spun off into a totally new world. That small rounding error had set off a chain reaction. This discovery became known as the butterfly effect, the idea that a butterfly flapping its wings in Beijing could, weeks later, cause a hurricane in New York. It sounds poetic, but it's also deeply scientific. It means small changes in initial conditions can create enormous and unpredictable results. The tiniest flicker, the smallest decision, can rewrite the story. It's a theory that's not just about weather, it's about life. Every moment, every choice, ripples outward. A single word of kindness, a missed train, a chance encounter. Each one could change everything in ways we'll never fully see. Lesson 2: Chaos is not disorder. It's a law of nature. When scientists first heard of Lorenz's findings, many thought chaos was just another word for randomness, for the messy, unexplainable leftovers that science hadn't yet solved. But they were wrong. What they found instead was that chaos had structure. It wasn't about things falling apart. It was about how complex systems actually behaved in the real world. Think about animal populations. When food is plentiful, populations rise. When it runs out, they fall. Simple enough. But when scientists added just one new variable, limited food, or disease, the results didn't stabilize. They oscillated. They spiraled. They danced on the edge of predictability. This was the universe whispering a truth we'd long ignored. Nature is nonlinear. Cause and effect don't always march in a straight line. One action doesn't always lead to one reaction. Sometimes, it leads to 100. The world isn't a clockwork machine ticking perfectly in rhythm. It's a living, breathing storm, dynamic, unpredictable, and astonishingly creative. Lesson 3: The Dynamic Systems Collective: The Rebels Who Mapped Chaos. By the 1970s, a small group of scientists decided to go all in. They called themselves the Dynamic Systems Collective, a mix of physicists, mathematicians, and dreamers. They didn't care about polishing theories for textbooks. They wanted to explore the edge of understanding itself. Armed with early computers, they ran experiments on everything from dripping faucets to planetary motion. They changed tiny details at the start, and watched entire systems evolve into unpredictable beauty. Patterns began to emerge: swirling fractals, spiraling feedback loops, self-similarity at every scale. It was as if the universe was painting in invisible brushstrokes, using chaos as its canvas. The collective realized something profound. Chaos doesn't destroy order, it creates it. It's the bridge between randomness and structure, the creative pulse of existence. Look closely at a fern leaf, a snowflake, a coastline, and you'll see it. Chaos is written into the fabric of nature. So what does chaos teach us? beyond science. That life is not meant to be perfectly predictable. That even in the moments that feel like breakdowns, the detours, the mistakes, the storms, something larger may be unfolding. Something beautifully ordered in its own wild way. Chaos reminds us that a tiny shift can change an entire lifetime. That systems, like people, are full of feedback loops, learning, adapting, evolving. And that the universe, for all its madness, still makes a kind of deep, hidden sense. Who should read Chaos? The 50-year-old scientist who still feels wonder at the stars. The 30-year-old dreamer who loves to connect dots between math, nature, and art. And the 17-year-old student who looks at the night sky and thinks, there's got to be a pattern in all of this. Because chaos isn't just about equations, it's about us. Our choices, our patterns, our tiny butterfly wings flapping through time. That was Chaos, by James Gleick. A story about how unpredictability became the most predictable truth in the universe.
We hope this book summary brought you joy and moments of reflection. Happy learning from Team Sapiens.